In this lecture, we introduce right censoring. So sometimes the data which is given to you is censored above a certain threshold. And this is also called right censoring. Now, if your data is censored, then you cannot use the standard linear regression model. And in this case, you have to use a censored regression model. So this censored regression model, a particular example of it is Tobit model. So we are going to use a Tobit model in this case. So let us see an example and understand what does this right censoring mean. So right censoring means you have the data censored above a certain threshold. So for example, you have a model where response variable is GPA, and this GPA has an upper limit of 4. So there is no information about GPA above 4. So 4 is your maximum possible. So there is no information above 4. So this data is censored above 4. So say there are two students who score exactly 4. Now their abilities could be different. One student could be better than the other, but both have scored a maximum of 4. So you cannot tell who is better. So this data is an example of censoring from above. So let us see the data in this format. So these are the response variables, and these are the predictors. So for us, the response variable has an upper bound. So the upper bound is 4. Notice that we are not making any assumptions about the predictors. We are not saying there is any bound on the predictors, writing score, reading score, math score, and the race of the student. So let us understand this data. So row 1 says that the student's GPA is 3.33. His writing score is 36, reading score is 39, math score is 50, race is 1. So race is a categorical variable. Row 2 says the student's GPA is 3.41, writing score is 38, reading score is 48, math score is 29, race is 2. Then row 3, GPA is 4. You have the writing, reading, and math scores. Race is 3. And then fourth row, GPA is 4. Again, writing score here is 19. Reading score is 25. Math score is 36. And race is 1. So notice that both these students have GPA 4. And this means that this data is censored above at 4. So there is a cap. This is already known to us. So you're given that there is an upper limit of 4. So pictorially, your model is like this. You have a black box here, which is your model, and this is a Tobit model. The response variable is the GPA, and this GPA is capped above at 4. So this GPA is less than or equal to 4. So since this is capped, you have to use a Tobit model. And there are 4 inputs into the model. There is a writing score, there is a reading score, there is a math score, and then there is race of the student. So let us do this in R. So you require the package VGAM. If you do not have the package, install it. So first you read the data set. So the data set is given here. This is the address of the file, and this is the name of the file. Header is true. So let us see the first 2 rows of the data set. You have writing score, reading score, math score. Then you're given the GPA of the student and the race of the student. This is row 2. Your writing score is 11, reading score is 25, math score is 22, GPA is 2.25, race is 1. So you focus on this. This is our model. So GPA has to come out of the model, and input into the model is your writing score, your reading score, your math score, and then you also have to put in race. But race is a categorical variable, so you have to make a factor out of it. So you say factor race. You factor in race. Now since this data is censored, you're already told that the upper limit is 4. So you use a Tobit model and put upper as 4. So upper limit is 4. Now data is D2. This is the data which we are feeding in, and then you run the model. and this will give us some values, the Pearson residuals, and this is exactly the formula which we have fed in here. So now let us see the coefficients of this model and interpret it. To interpret the coefficients, we have to start with the z values. So notice that there are no p values which are coming out, or confidence intervals, so we have to start with z values. So the idea is this: you take the z value and take its absolute value. Absolute value means if it is a negative, you drop the negative sign in front of it. If it is positive, you keep it as such. So you take the absolute z value and check if it is greater than or equal to 2. Now if it is greater or equal to 2, you take it as significant. If it is less than 2, then it is not significant. So notice this is 5.66. This is greater than 2. So this is significant. So this was positive, so we did not do any change. This is minus 21.3. So make it positive. This becomes 21.3. This is also greater than 2. So this is also significant. This is minus 0.59. Make it positive. This becomes 0.59, but this is less than 2. So this is not significant. This is 4.39. This is greater than 2. So this is significant. 8.3 is greater than 2. This is significant. 2.6 is greater than 2. This is significant. 3.2 is greater than 2. So this is significant. So we start with interpretation now. So for intercept 1, this is exactly the same as in linear regression. This intercept 2, this talks about standard deviation. You exponentiate it, you get the standard deviation. Now before we start interpreting these scores, I want to make a very important remark. So there are two steps to interpreting this. One is when the GPA is less than 4. So if the GPA is less than 4, you interpret it precisely in the manner you interpret linear regression. So you just have linear regression and you interpret it precisely the same way. If the GPA is exactly 4, you cannot use the same interpretation as of linear regression. Now in that case, you first have to compute the probability of GPA being 4. Now that is easy. You count the number of observations which have GPA 4 and you divide it by total number of observations. So you have the probability of GPA being 4. You take this probability and then you weight each of these scores with this probability. So once you do that, then you can have a new interpretation on impact of writing score, reading score, math score, and the race on the GPA. That is, if the GPA is 4 for 2 students, you can tell which student is better than the other. Now we are not going to do this part because this is slightly more complicated, and the best way to deal with this part 2 is to conduct a separate study for people who have GPA 4. So that will give you more clarity rather than using the same model. So we are going to stick with part 1, and for part 2 it is advisable to conduct a separate study, or you can use the same study by computing the probability and weighting the coefficients with this probability. So let us now interpret these coefficients. So we have seen that the writing score is not significant, so we are not going to touch it. So this has to be dropped from the model. So we have the reading score. So 1 unit increase in reading score will increase your GPA by 0.0204. 1 unit increase in math score will increase your GPA by 0.04. Now if your race changes from 1 to 2, your GPA will increase by 0.16. If your race changes from 1 to 3, your GPA will increase by 0.22. So notice that we are not talking about difference between 2 and 3. We are just talking about difference from 1 to 2 and 1 to 3. So now we have to make a new model in which we drop the writing score, and then we can do some prediction. So you have a new model, model 2. Now GPA is a function of reading score and math score. So we have dropped the writing score and the race because the race is also significant. Now again, Tobit upper is 4 because 4 is the upper limit, and the data we use is D2. So you construct the data frame. Your reading score is 40, 40, 40. Your math score is also 40, 40, 40. And your race is 1, 2, 3. This is 1, 2, 3. So then you use the predict command. You're going to predict model 2. You're going to give in this data frame into the model. Your type is response. So this is S1 as the data frame. This is precisely this data frame. So you feed in row 1. Your GPA comes out to be 3.43. So this goes into your model. and the model gives you output of 3.43. So this row goes into your model and the model gives an output of 3.60. This third row goes into your model and the model gives the output of 3.66. So now you can see that as you change the race and keep everything constant, so from 1 to 2 there is a change of 3.60, and you can see from 1 to 3 there is a change of 3.66. So that is pretty much it. You basically take this value and add 0.16 to it, you get 3.60. Then you take 3.43 and add 0.22 to it, so you get 3.66. So this is the model, the prediction of the model. Now if you take the minimum of GPA, so a minimum of D2 is your data set, $GPA means it will take the column GPA, compute its minimum value, it comes out to be 1.76. Once you have this value, you need to ask the class teacher, why does this value come? So the class teacher could say that all the students are capable enough to score 1.76. Now in that case, you do not need to do anything, your model is sufficient. But in case the class teacher tells you that we have already decided to give the minimum GPA as 1.76, that is, anyone who enrolls in the class automatically gets a GPA of 1.76, say based upon the attendance or something else. So in that case, you know that the model is now censored from below. So there is a minimum threshold. So there is a minimum threshold. Now if there is a minimum threshold, that is, data is also censored from below, then you need to change your model again. So in this case, you have model 2. Your GPA is again a function of reading score, math score, and factor. Notice that we have already dropped the writing score from here. And your Tobit model is, you have upper is 4 and lower is 1.76. So you have upper censoring of 4 and a lower censoring of 1.76. So you have upper censoring of 4 and you also have a lower censoring. Again, your data set is just D2 and you have a data frame. Your reading score is 40 40 40. Your math score is also 40 40 40. Your race is 1 2 3. You take this S1 data frame and now you put it in model 2. Your type is response. You put in 40 41. Your GPA comes out to be 3.43. So input is this, output would be this. Now you feed in row 2 into your model. Reading score is 40, math score is 40, race is 2. It will give you 3.60. Then row 3, you feed in reading score is 40, math score is 40, race is 3. It will give you 3.67. So notice that now we have been able to construct a new model in which there is both upper censoring and lower censoring. But you need to understand where this data comes from and why there is a upper censoring and a lower censoring. For example, in this case, we found out there was upper censoring, but we had to ask the class teacher and closely look at the data to understand if there was a lower censoring too.